Welcome back. Section 2.4. In this section, we will discuss dividing polynomials and the remainder and factor theorems. We will also use long division to divide polynomials. We will use a more abbreviated version of long division, which is called synthetic division to divide polynomials. We will evaluate a polynomial using the factor theorem and the remainder theorem, that is, and then use the factor theorem to solve a polynomial equation. In the next example, we will illustrate how to use long division of polynomials. All right, to set up the problem, the dividend, so this is x plus 9 divided into, our divisor is x plus 9. So this is x squared plus 14x plus 45 divided by x plus 9. So your divisor is x plus 9. The dividend is x squared plus 14x plus 45. All right, so to begin the division process, we divide x divided into x squared. X divided into x squared, or another way of saying this is x squared divided by x is x. And now we multiply. X times x is x squared. X times 9 is a positive 9x. Draw the line and subtract. All right, we're going to subtract. Just as we did in long division using arithmetic. Same process. So now that we subtract, a minus x squared plus x squared cancels out. A negative 9x plus 14x is 5x. Bring down the next term, which is 45. And now repeat the process. X divided into 5x is a positive 5. And now we multiply. Quotient times divisor. 5 times x is 5x. 5 times 9 is a positive 45. And now we subtract. This becomes a negative 5x and a negative 45. Upon subtracting, a negative 5x plus 5x is 0. A negative 45 plus 45 is also 0. So the quotient is x plus 5 with a 0 remainder. And notice again, we divided, we multiplied, subtract, and we brought down the next term. Let's now discuss the division algorithm. Polynomial long division is checked by multiplying the divisor by the quotient and then adding the remainder. So this process illustrates what we call the division algorithm. We have here the f of x is the dividend. We have our divisor, and of course the quotient, and the remainder. So we could actually express the dividend, as we said, as the product of the divisor times the quotient plus the remainder. Let's consider another example involving long division. So we want to divide 7 minus 11x minus 3x squared plus 2x cubed by x minus 3. All right, so our divisor is x minus 3 divided into the dividend. It is important that we express the dividend in what is called descending order of powers in x. So we have 2x cubed minus 3x squared minus 11x plus 7. So it's important first to, if you have to rewrite the dividend in descending order. And now we begin the process. We divide x into 2x cubed. X divided into 2x cubed is 2x squared. And now we multiply. 2x squared times x is 2x cubed. 2x squared times the negative 3 is a negative 6x squared. Draw the line and subtract. Subtract by changing the signs here. So we have a negative 2x cubed and a positive 2x cubed, 0. A positive 6x squared plus a negative 3. X squared is a positive 3x squared. Now bring down the next term. The next term is a negative 11x. Repeat the process. X divided into 3x squared is a positive 3x. And now multiply. 3x times x is 3x squared. 3x times a positive 3 is a positive 9x. And now subtract. This becomes a negative 3x squared and a negative 9x. A negative 3x squared plus a positive 3x squared cancels out. A negative 9x plus 11x becomes, so this is positive, a negative 2x. And now bring down the next term, which is a positive 7. Repeat the division process. So x divided into a negative 2x is a negative 2. And now we multiply. A negative 2 times x is a negative 2x. A negative 2 times a positive 3 is, that's a negative 3. Negative 3, be careful. A negative 2 times a negative 3 is a positive 6. Be careful. Draw the line and subtract. When we subtract, we get a positive 2x plus a negative 2x cancels. This is a negative 6 plus 7 is a positive 1. So the quotient is 2x squared plus 3x minus 2 with a remainder of 1. And if you like, you can express the result in the form quotient plus remainder divided by divisor. So we can actually express our answer as 2x squared plus 3x minus 2 plus 1 over x minus 3. Now let's consider dividing polynomials using synthetic division. We can use synthetic division to divide polynomials if the divisor is of the form x minus c. By using synthetic division, we are then able to obtain a quotient more quickly than using long division. Okay, let's look at an example using synthetic division to divide 5x cubed plus 6x plus 8 by x plus 2. All right, so the first step, all right, we said that we wanted the divisor to be at the form x minus c. So that means then that for x plus 2, that's x minus a minus 2. So that means that c is a negative 2. All right? We'll talk about that in a little second. Let's set this up for synthetic division. All right? So, but first of all, let me just say in long division, it would be x plus 2 divided into 5x cubed. Now, as I indicated earlier, the dividend has to be expressed in descending order of powers in x. Now, if there's a missing term, we include it with a coefficient of 0. For instance, we go 5x cubed to 6x. So the x squared term is missing. So we add in the missing term with a coefficient of 0. So that's 0 times x squared plus 6x plus 8. So that's the way we would set the problem up using long division. We want to use here synthetic division. So we've written the divisor, x plus 2, in the form x minus c. So that means that c is a negative 2. All right, so this is what we do in synthetic division. All right, so c is a negative 2, so write a negative 2. All right. So we're writing c to represent our divisor. And now we want to write only the coefficients of each term in the dividend. So we have 5, 0, 6, and 8. And now, all right, the leading coefficient here is 5. Let's just bring this down to the bottom row. 5. That's what we do. And now we're going to multiply c. C in this case is a negative 2. C is a negative 2. So we're going to multiply c now by the number in the bottom row, which is the 5. So this is a negative 2. A negative 2 times 5. A negative 2 times 5 is a negative 10. Now we add. A negative 10 plus 0 is a negative 10. And now we multiply c by a negative 10. C is a negative 2. So a negative 2 times a negative 10 is a positive 20. A positive 20 plus 6 is 26. And now a negative 2 times 26 is, so I'm multiplying, a negative 2 times 26 is a negative 52. And now we add. A negative 52 plus 8 is a negative 44. All right? So now the bottom row represents the quotient upon dividing by x plus 2. So the quotient becomes we started with the degree of x cubed, so the quotient is 1 degree less than that of the dividend. So this is going to be 5x squared minus, now the 10x, the x term, plus 26. All right? This term represents the remainder. So if we were to express this, so what we have here is that the quotient plus the remainder, we have 5x squared minus 10x plus 26 plus a negative 44 divided by x plus 2. All right, so this is our answer. The remainder theorem. If the polynomial function f of x is divided by x minus c, then the remainder is merely f evaluated at c, f of c. Let's see why this is the case. Well, we stated that the division algorithm could be expressed as the divisor times the quotient plus the remainder. That's the division algorithm. Now, our divisor divided by x minus c, which is your divisor. All right, so let's, instead of writing d of x, the divisor, as a function of x, let's just say it's x minus c. All right? So therefore, I can express f of c as c minus c times q of c plus the remainder. So what are we getting here? So we get clearly that then f of c is the remainder. And that's the result, the conclusion of the remainder theorem. That the remainder can be expressed as f of c. Let's look at an example of the remainder theorem. So given the function f of x is equal to 3x cubed plus 4x squared minus 5x plus 3, use the remainder theorem to evaluate f of minus 4. So we're going to use the remainder theorem to evaluate the polynomial function at a negative 4, rather than merely just substituting a negative 4 for x and then performing the indicated operations. All right, if we use the remainder theorem, well, we're dividing by, all right, let's say that, we're dividing by x minus c, but in this case, this is, you can write this as x minus a minus 4. So this implies that c is equal to a negative 4. All right, we're going to use synthetic division to answer the question, to find f of minus 4. All right, so our divisor, c, is a negative 4. And the dividend, and recall that we only list the coefficients of each term in the dividend. So we got 3 4, a negative 5, and 3. Bring down the leading coefficient to the bottom row. Once we do that, we begin the multiplication. So that's a negative 4 times 3 is a negative 12. A negative 12 plus 4 is a negative 8. A negative 4 times a negative 8 is a positive 32. And now we add a positive 32 plus a negative 5 is a positive 27. A negative 4 times 27 is a negative 108. A negative 108 plus 3 is a negative 105. So therefore, as a result of the remainder theorem, we now can conclude that f of a minus 4 is equal to what? The remainder, which is a negative 105. We now introduce the factor theorem. The factor theorem states that letting f of x be a polynomial function, and if f of c is equal to 0, then x minus c is a factor. If x minus c is a factor of f of x, then f of c is equal to 0. So we will show how the factor theorem is actually used to solve a polynomial equation. Okay? Let's look at an example here of the factor theorem. So we want to actually solve the equation 15x cubed plus 14x squared minus 3x minus 2 is equal to 0. Given that minus 1 is a 0 of the polynomial function, f of x is equal to 5x cubed plus 14x squared minus 3x minus 2. All right, let's see what's happening. But before we start, f of x, this is 15. That leading coefficient, that should be 15x cubed plus 14x squared minus 3x minus 2. So it says that minus 1 is a 0. All right, if minus 1 is a 0, then from the factor theorem, we know then that x minus a minus 1 is a factor. All right, c in this case is a negative 1. But x minus a minus 1 is x plus 1. All right, now let's see if we can now solve the equation given this information. All right, so if we can find the other zeros, all right, then we would have found the solution, or the roots of this cubic equation. All right, so let's use synthetic division to check. So let's see. So we know that a negative 1 is a 0. So if a negative 1 is a 0, I can use synthetic division. Remember synthetic division, we want to just write the coefficients of each term. So this is 15 of the dividend. This is 15 plus 14 minus 3 minus 2. Bring down the leading coefficient 15 and begin multiplying. So we have a negative 1 times 15, which is a negative 15. add a negative 15 plus 14 is a negative 1. A negative 1 times a negative 1 is a positive 1. Positive 1 minus 3, or positive 1 plus a negative 3 is a negative 2. A negative 1 times a negative 2 is a positive 2. Plus 2 minus 2 is 0. So then the quotient, upon dividing by x plus 1, the quotient then becomes, using the coefficients of the bottom row, this becomes 15. We started with x cubed, so it has to be 15x squared minus x minus 2. All right, so we basically want to now solve this. All right, continuing the process. We want to solve that equation. All right, so let's see. Can we factor this? Let's see if we can solve this quadratic equation by factoring. Yes, we have 3x plus 1 times 5x minus 2. And you should check to make sure that we have the correct factors here. Okay, 3x times 5x is 15x squared, and 5x plus a negative 6x is a negative x, and then finally a positive 1 times a negative 2 is a negative 2. All right, now if we use a zero product principle, we have that 3x plus 1 is equal to 0, and 5x minus 2 is equal to 0. So 3x is equal to a negative 1, x is equal to a negative 1/3, over here. 5x is equal to 2, x is equal to 2/5. So, the solutions, so let's say that the solution are all right, minus 1, a negative 1/3, and 2/5.